study by Jamieson Garrell et al. Explores the concept of Hamilton's rule. Hamilton's rule is based on the theory of kin selection of altruistic behaviours. An altruistic behaviour is when an individual puts themselves on the line for the benefit of another. A good example of this is when a red female squirrel adopts an orphaned pup so that the pup will survive. Hamilton's rule explains that this behaviour towards relatives has evolved because it can improve the inclusive fitness of the adoptive female. If the female saves the pup of a mother who was closely related to her, then there's an increased chance of that female's genes being passed down to future generations. The aim of this investigation is to determine the accuracy of the theory behind Hamilton's rule. The study was conducted over 19 years in Yukon, Canada. It involved a single study population where 2,230 litters of red squirrels were monitored. This resulted in a complete maternal pedigree. The monitoring included observing the deaths of females that had recently given birth, whether an adoption occurred after these deaths, and if one did, what was the level of relatedness between the mother and the adopting female. The level of relatedness is applied to Hamilton's formula, which is displayed on this slide. The level of relatedness is determined by the pedigree and then is applied to the other factors. If the fitness cost to the adopting female is lower than the fitness benefit to the orphan times the level of relatedness, then Hamilton's rule is satisfied. There are 5 cases where females adopted an orphaned pup, and these are represented by the solid dots. In each of these, the adoptive mother was closely related to the deceased mother. In 29 cases, the mother died and there was no adoption. In 27 of these, there were no closely related females nearby. However, in 2 of them, there were related females close by. But the coefficient of relatedness was too low to satisfy Hamilton's rule. That is, the cost to the female would have been too high. And these are represented by the white dots. This line represents the cutoff point for Hamilton's rule. Squirrels are very asocial animals, which means they don't form strong social bonds. This makes them ideal for this study, as they don't have any previous relationships that will affect the chance of adoption. Hamilton's rule in each adoption case revealed that the benefits of passing on their own genes by adopting an orphan outweighed the cost of their own litter. Importantly, only 1 pup was ever adopted through the litter, even though the litter was often larger. This can be seen in this table. When the litter size was larger than 1, the inclusive fitness of adopting the juveniles has a negative value, which means it would not have been beneficial to the adopting female. In conclusion, although females had the opportunity to break Hamilton's rule by either adopting an unrelated juvenile or adopting more than 1 related juvenile, they never did. It can be seen by these results that the study clearly supported Hamilton's rule. There was an updated study in 2013 by Corey Williams et al., where the same squirrel population was observed for 3 more years. Thank you.